Okay, this is finding the quadratic equation, part 1. And what we're going to do here is we're going to give you some clues. So in this example, we're going to try to find the equation given. One of the clues, and a big clue, is where exactly is the vertex. Now these are quadratic equations, so we know they're going to be parabolas. So we know there's going to be a vertex, and they're just being so nice that we're going to give you the parabola here, or sorry, the vertex here. So we know where the vertex is, and there's a lot of parabolas that have this particular vertex, but so what we're going to do is give you one more point. So this is given a vertex and a point that's on the parabola. And the point that we have here is the point 2, 2. Okay, so this is a point on the graph, and we have the vertex, and our job is to find the quadratic equation. A really good way to start. So I'm going to clear the screen here, and I'm going to bring up the grid. So a really good way to start is to get yourself a bit of a picture. So there's our grid, and what I'm going to do is plot the vertex. So the vertex here is at -2, -3. So there it is, and we have this other point, 2, 2. That's a point that's on the graph. Now, if this is the vertex, keep in mind that that means the axis of symmetry must be going up through -2. So we know that the thing is symmetrical about this line. So that means I could just beam another point. Let's see, we are 4 units away from the axis of symmetry. We could just beam it 4 units across to here. So we know there's another point over there. And now if I wanted to, I could connect all these points together, which I'm going to try to do here. And this would be the graph. Now, this is supposed to be smoother here, so I apologize. It's tricky to draw. All right, not too bad. It's not as round as it should have been around the vertex, but it's a picture. So, what do we know about a quadratic equation? Well, we know that the basic graph would look, the basic equation looks something like this. A times, and then we have x minus some number h, or it could be plus a number squared, plus or minus some number that's tacked on. And what we know is that every vertex is at the location of h. Now, h is the number that turns this to 0. And when you plug in h, of course, this does become 0, which wipes out the squared and the times a, and you're left with k as the y-coordinate. So that's where every vertex is. Now, they tell us that the vertex is at -2, -3. That gives me a lot of pieces of my equation. So I don't know what a is, but I know that this is going to be x. Now, we know the vertex here is at -2. So theoretically speaking, h would be -2. And if I plug that in here, that's going to be like a double negative. So I'm going to have x plus 2 squared. Now, as a check, keep in mind, we're trying to make this 0. And if I put -2 in where the x is, that will be 0. So that's kind of a check that, yes, we got our signs correct. The next thing is the number k at the end, and that one's a little bit easier. It's kind of pretty obvious that we want to go to -3. So minus 3. Now that gives me almost everything in the equation except for a. See, this is the only thing that I didn't figure out. And to figure that out, we simply take one of these points here. And I'm going to use this point here because it was given to us. And it's the point 2, 2. Well, if it's a point on the parabola, that means if I put a 2 in where the x is and a 2 in where the y is, then the left side and the right side of this equation have to be the same. So that's going to give me a way to figure out what a is. So, don't know a. We know x is 2. So we're going to plug it in, squared, and then we have minus 3. Okay, so what do we got here? We got 2 equals 4, and 4 squared is 16. So that's 16 times a. And I spun this around because it looks a little better. Then we have minus 3. So I'm going to add the 3 over to this side, and that equals 16a. And now I'm just going to divide by 16. So here's what a is. 5/16. So now I know what a is, and basically I already have the x plus 2 squared and the minus 3. So the equation of this graph, maybe we'll just write it up here, would look like this. I would have either y or f of x equals, and then we would have 5/16, then in brackets, x plus 2 squared, and then minus 3. Okay? So that's how it's done if you're given a vertex and 1 point. Now, it's a lot more work if they don't give you the vertex. So these are the nice questions when the vertex is given. So what we're going to do, we're going to stop there, and we're going to come back and show you the ones where you don't have that nice little vertex given to you. Okay?